Welcome to VVV Plus. So in this video, we are going to continue the previous session of Rutherford model. In the previous video, we discussed about how Rutherford discovered the structure of atom. So now we are going to summarize his conclusion and we are going to discuss about the limitation in the model. So whatever the invention comes, definitely there will be some limitation. So here we are going to discuss about his conclusion and some limitations. So let's come to the Rutherford model of an atom. So what he concluded first is, it's very simple. An atom consists of a small and massive central core in which the entire positive charge and at most the whole mass of the atom is concentrated. This core is called a nucleus. So what is that meaning? So if you take an atom, the entire mass of the atom is concentrated only at the center part of the atom, which is called as nucleus. That nucleus is completely made up of a positively charged. So this is the first thing what he concluded. Then when it comes to the second point, it's quite interesting. The size of the nucleus is around 10 power minus 15 meter. It's very small as compared to the size of the atom. For just a reference, I'm just telling you, if suppose we consider the size of the nucleus as a football, then obviously the radius of the atom is going to be a 5 kilometer radius. So just compare the size ratio. So that's what he concluded. If the size of the nucleus is 10 power minus 15, then the size of the atom is 10 power minus 11. So it's approximately 10,000 times bigger. So this is what the second conclusion what he did. Now when it comes to the third point, the nucleus is completely surrounded by the electron, which is equal to the number of the protons, in order to make the atom electrically neutral, so that there will be no other excess charges flowing. So this is what he concluded as the third most important point. The nucleus is surrounded by a suitable number of electrons. What does it mean by the term suitable number of electrons? Which means the number of electrons should always equal to the number of protons, so that their total negative charge is equal to the total positive charge of the nucleus of the atom. So the whole atom is electrically neutral. Let's consider, suppose an atom holds 24 electron, then obviously it will hold 24 proton inside the nucleus. That's why the total atom will becomes an electrically neutral. Then the next point, the electrons revolve around the nucleus. We all know that, just like a planetary motion, just placing the sun at the center and earth and other planets are revolving around the sun. Similar to that, the atom also follows the same rules. Just like the nucleus will be at the center of the atom, then the rest of the electrons will move around the nucleus. But what Rutherford said is, nucleus is at the center, but the electrons will move in random orbits. It's not like a fixed or stationary path. It can move in any orbits. So this is what he concluded. The electron revolves around the nucleus in various orbits, just as the planet revolves around the sun. Okay. Whenever it's revolving, the centripetal force required for the revolution is provided by the electrostatic attraction between the electrons and the nucleus. We know that the unlike charges will always tend to attract each other. So that's why whenever the electrons are trying to revolve and move away, the electrostatic attraction force due to the nucleus, which holds the positive charge, will never let the electrons to move away. So this is what the point what he concluded. So next, let's come to the limitation point. So limitation point, in the sense, only major two limitations are there we are going to address. One is based upon its path. Okay. So first thing, according to electromagnetic theory, we are familiar about the electromagnetism. What is electromagnetism? Whenever a charged particle oscillates, it tends to emit electromagnetic waves. Similar to the scenario, when it comes to atom, the electrons will revolve around the nucleus. When the electrons is revolving around the nucleus, it is taken as a charged particle, it's revolving, so it will start emitting the electromagnetic waves, or simply we can say it loses its energy. So if that is the case, if it starts losing the energy, then after a certain moment it will start coming following a spiral path and will fall inside the nucleus, because nucleus is a positive charge, it will easily attract. Then obviously the total atom will get damaged, or we can say it will be destroyed. But in reality it's not happening. Why it's not happening? That's what we are going to discuss now. So according to electromagnetic theory, an accelerated charged particle must radiate an electromagnetic energy. So this is what we know already pretty well. This topic you will be discussed in the electromagnetic waves chapter. Next, similar to that, an electron revolving around the nucleus is under continuous acceleration towards the center. So whenever the electrons are revolving around the nucleus, it will also be facing a continuous acceleration towards the center of the nucleus. Now, as a result, it should continuously lose energy and move in orbits of gradually decreasing, just like a spiral or helical path. It will just follow a circular path and it will reach us the nucleus. The electrons should follow a spiral path, okay, and finally it should collapse into the nucleus. It will fall into the nucleus. Now, thus the Rutherford model atom cannot explain the stability. So as a result, the atoms are not stable. So Rutherford failed to explain this one point, why the atom is not a stable thing. But in reality the atom is stable. But as per his conclusion, if his theory was correct, then the atom will be not stable. But in reality the atom is stable. So the next upgradation of this limitation was given by Bohr's model. So let's discuss about what the changes was Bohr done. Okay. Now there is another one more point in order to justify this. So Rutherford model, an electron can revolve in orbits of all possible radii. So this is where the contradiction starts. He mentioned that the electron will revolve in all the possible radius, but Bohr just remodified this one point. Then so it should emit a continuous spectrum. We all know that. What is the spectrum? Whenever the electrons is moving from higher energy state to lower energy state, it will lose its energy. That is known as higher energy spectrums. So, but an atom like hydrogen always emits a discrete line spectrum. Discrete in the sense individual lines, okay, individual energy. This point also is not explained by Rutherford. Later Bohr explained all these points in a detailed manner. So let's discuss about the upgradation of the structure of atom by Bohr in the next video. So don't forget to follow us. Thank you for watching this video. Have a good day.